Yeah, but sure. That's an interesting thing about the actually it's interesting because when Yana was talking, I was thinking about like one of the related problems is that like when people are navigating through different sources, right? They have different granularity of timing and like logs. If you have a different timestamp, even if your trace is more correct, if another one doesn't have exactly the same one, it can be and this kind of leads into your question. What sorts of things? Like the first thing we did was basically just copy paste what Twitter was already doing, which was effectively a query time, sort of stretching out the graph, if you will, to make it look less weird. So for example, if it would basically like just split the difference and then assume that like a parent should never be able to be born before it should, the parent-child relationships, using the structural data to make it look less strange. Probably other systems might do that if they're presenting a trace graph, because sometimes the actual like distance is, as far as people interpreting that as latency, is the important thing. But the other thing is like in understanding the actual call graph, and if something is on the wrong side of the screen, that can actually have more severe effects than cognition, I think. Like and so it's kind of a dumb thing, but we do that. One thing we haven't done is and for years we sort of talked about it, which is sort of like a bug view of the trace, like showing all the things that look off to us, meaning that like where's the small data wrong or moved, or like where we're lost a parent and blah blah blah. And I would say clock drift is in that classification of adjustments where you sort of just adjust where you can. How do we reduce the data problem though? So we don't try to use any custom clock source or things like that. So the general question that we have is like from folks, it would be to just try your best to use like even old services that used to exist, NTP or whatever, to try to get your host clocks as close as you can. Now, the question about instrumentation, and that's like, a fancy word for the driver inside of your app that's collecting data. So that part, we have something very specific, and that was really kind of, at least in the Java space, we had to do some funny things, because what was happening was we would have drift in the same trace, and not only in the same trace, but the same part of it. By the time the request moved from one side of the process to the other, the clock would change. And so you would have things like negative durations and weird things. And so what we do, and I think a lot of other libraries do this now, but you effectively will pin the clock at the entry point into the process, and then just use relative monatomic time after that. And that means that even if the logs might be slightly messed for that specific request and what we call a local root, the fragment that is in that process, it's better, because at least as Jaana said, people over rely on timestamps for guessing things, and at least within the process, using monatomic time, it would be better. And so if they're trying to say like, did something happen before the other one or not, and you can't tell because they're all peers, you at least know. I mean, you have a better answer. It won't be correct, but it will be less incorrect. And so that's one thing that we do. And that came out of a use case from Samsung Smart Things, which is like an IoT thing. And they were having these things where like they're trying to debug some highly parallel stuff, and it's just harder to do unless you can freeze something. And so we just freeze the clock for that point where it hits, which we call the local root, until everything else exits. They all use the same clock tick.
This is really relevant to what we were trying to do, but we couldn't do as much as that you did by relying on the same initial point and only increasing from that, like by implementing your own monotonic clock basically in this same process. What we ended up doing is like, at least in the span, we always like rely on the monotonic clock to calculate the duration. But the next time that you are creating a span, you are still relying on the wall clock. So there's all this like, in the same process, as you mentioned, there's all these like funny situations. If we have time, I actually want to follow up with a question to you. you mentioned that you did some fixing, so like a child never shows up before the parent. In my experience, I realized that like people realize that there's clock drift, and they're suffering from that by seeing it themselves. Like I've seen customers like looking at the distributed trace and realizing for the first time that like a child is happening from the parent. How is that possible? And then they immediately realize that there is a clock drift. And that's when I decided like, hey, we shouldn't do something about this maybe in the visualization, because it
Mm.
actually helps them to realize what's going on. So that was interesting to hear that like you went the other way.
Yeah, it's just the imperfection of of optimizations, right? So like people who have no idea about the sense of clock drift, you have to bring like a lot of things to that table before it would be understandable, and especially with like like a mobile thing or whatever with the minutes difference. But I would say that's also the second half of it was like what is the sort of like bug we created in that, which is that it would be nice. We haven't done it, right? But it could be done to have like the buggy view, and where it shows like, okay, here are the things, here's the real, so that and maybe some hints, like some annotations, like lines are a bit fuzzy or something like that, to just hint people that things, including clock and also like missing parents, that are sort of like estimated to be put into a spot. Because you're right, especially the more technical folks will notice that, and currently we don't have the best experience. So that means is that like if there's a question, we just say like click on the JSON, it has the authoritative data. The first Zipkin wouldn't even let you do that. So what happened was in the like circa 2015 one, all of that logic was happening server side. So the browser could never even present that. So one of the reasons why we switched, I mean, just there's a technical reason too. Like it's easier to just do this stuff in JavaScript, but one of the biggest problems was that people could have no participation in whether or not they're seeing the real data or not. So we had to actually create a special query called like raw back in the day to just stop it from doing that, for the exact reasons you're mentioning, which is that like people couldn't even know in any way. So now it's sort of like it's still under the rug, but you can lift up the rug by hitting the JSON button. And the next step from that logically would be to just say, okay, well, here's what it looks like. Enjoy.